Students, we are given this question. The choices are there. Please pause the video, work the question out and zero in the correct choice. When we return, we will see how to obtain the correct solution and check our solutions also. Okay, foremost what I wish to do is I would like to consider integral 0 to 4 pi e raised to the power of t times sine raised to the power of 6at positive cos raised to the power of 4at times dt. I would like to rewrite this as 0 to pi e raised to the power of t of sine raised to the power of 6at positive cos raised to the power of 4at times dt. Positive, it's 0 to pi, right? So the next one is going to be pi to 2 pi e raised to the power of t times sine raised to the power of 6at positive cos raised to the power of 4at times dt. Positive, this is pi to 2 pi. The next one is going to be 2 pi to 3 pi e raised to the power of t times of sine raised to the power of 6at positive cos raised to the power of 4at times dt. So the next component is going to be from 3 pi to 4 pi e raised to the power of t of sine raised to the power of 6at positive cos raised to the power of 4at times dt. So this is what we have got. Now I'm going to be representing it in the following fashion. So let me take the left hand side to be equal to I1, and this one is going to be I2, this is going to be I3, this is I4, the last one is going to be I5. Now I suffix 3, which is integral pi to 2 pi e raised to the power of t of sine raised to the power of 6at positive cos raised to the power of 4at times dt. Now let me take t to be equal to pi positive x, so dt will be equal to dx. So when t is equal to pi, my x will be equal to 0. When t is equal to 2 pi, my x will be equal to pi. So I the suffix 3 is going to be integral 0 to pi e raised to the power of t is pi positive x. Now if I were to substitute t as pi positive x, it will revert back to us the same component, okay, because of the power being even here. So this is going to be producing me sine raised to the power of 6 a times x positive cos raised to the power of 4 a times x times dx. I can rewrite this as integral 0 to pi e raised to the power of pi times e raised to the power of x times sine raised to the power of 6 ax positive cos raised to the power of 4 ax times dx. I can rewrite this further as e raised to the power of pi times integral 0 to pi e raised to the power of x times sine raised to the power of 6 ax positive cos raised to the power of 4 ax times dx. Now this is going to be e raised to the power of pi. Now I can clearly revert back to the initial variable integral 0 to pi e raised to the power of t, no harm in it because it's just x all through, so we can always have it substituted by another variable. So this is sine raised to the power of 6 a times t positive cos raised to the power of 4 a times t times dt. But what is this? This is nothing but e raised to the power of pi times I suffix 2. On the left you got I suffix 3. So we have successfully represented I suffix 3 in terms of I suffix 2. Now let me consider the next quantity. I suffix 4 is equal to, this is 2 pi to 3 pi, right, e raised to the power of t times sine raised to the power of 6at positive cos raised to the power of 4at times dt. Now let me take t to be equal to 2 pi positive x. So my dt is going to be my dx, and when x is, or I would say when t is equal to 2 pi, I get x is equal to 0. When t is equal to 3 pi, I get x is equal to pi. So clearly I suffix 4 is going to be integral 0 to pi. Now following the same concept, right, this is going to be e raised to the power of pi times e raised to the power of t times sine raised to the power of 6at positive cos raised to the power of 4at times dt, which is going to be e raised to the power of pi times integral 0 to pi e raised to the power of t times sine raised to the power of 6 at positive cos raised to the power of 4 times at times dt, which is going to be e raised to the power of pi times I suffix 2. So you have I suffix 4 is equal to e raised to the power of pi, and one small change here. So because we are making the substitution as 2 pi, so this is going to be 2 pi. Okay, this is going to be 2 pi because the substitution is t is equal to 2 pi positive x. So I suffix 4 is going to be e raised to the power of 2 pi times I suffix 2. So following the above principle, if you were to write I suffix 4, it's going to be 0 to pi e raised to the power of 2 pi times e raised to the power of t times sine raised to the power of 6 at positive cos raised to the power of 4 at times dt, which could be rewritten as e raised to the power of 2 pi integral 0 to pi e raised to the power of t times sine raised to the power of 6 at positive cos raised to the power of 4 at times dt. This is going to be equal to e raised to the power of 2 pi times I suffix 2. So you have I suffix 4 to be equal to I suffix 2 times e raised to the power of 2 pi. Now let me consider our I suffix 5, which is going to be integral. Initially it was 2 pi to 3 pi, so this is going to be from 3 pi to 4 pi e raised to the power of t times sine raised to the power of 6 at positive cos raised to the power of 4 at times dt. Now let me take t to be equal to 3 pi positive x. So when t is equal to 3 pi, my x is equal to 0. When t is equal to 4 pi, my x is equal to pi. So this is going to be equal to 0 to pi e raised to the power of 3 pi positive x sine raised to the power of 6. Now in place of t, you are substituting 3 pi positive x, so it will revert back to at sine raised to the power of 6 at positive cos raised to the power of 4 at times dt. So this is in actually we need to have it as x. Now probably in the next step I will revert everything back. So this is 0 to pi e raised to the power of 3 pi times e raised to the power of x times sine raised to the power of 6 ax positive cos raised to the power of 4 ax times dx, which is equal to e raised to the power of 3 pi integral 0 to pi e raised to the power of t times sine raised to the power of 6 at positive cos raised to the power of 4 at times dt, which is rewritten as e raised to the power of 3 pi times I suffix 2. On the left you have I suffix 5. So this is how we rewrite the integrals. So let's proceed. Now if you remember, we started off like this: I suffix 1 is equal to I suffix 2 positive I suffix 3 positive I suffix 4 positive I suffix 5, and we add a relationship like this: I suffix 3 is e raised to the power of pi times I suffix 2, I suffix 4 is e raised to the power of 2 pi, I suffix 2, I suffix 5 is e raised to the power of 3 pi times I suffix 2. So we will be substituting these terms using these terms. So hence I have I suffix 1 is equal to I suffix 2 positive e raised to the power of pi, I suffix 2 positive e raised to the power of 2 pi, I suffix 2 positive e raised to the power of 3 pi, I suffix 3. I can take I suffix 2 out, so this is going to give me e raised to the power of pi positive e raised to the power of 2 pi positive e raised to the power of 3 pi times I suffix 2, and on the left I have I suffix 1. So in place of I1 we will have to use this. But what is this I suffix 2 and what is this I suffix 1? So this is actually 0 to 4 pi e raised to the power of t times sine raised to the power of 6 at positive cos raised to the power of 4 at times dt. This is equal to 1 positive e raised to the power of pi positive e raised to the power of 2 pi positive e raised to the power of 3 pi times I suffix 2. Now what did we have for I suffix 2? I suffix 2 is integral 0 to pi e raised to the power of t times sine raised to the power of 6 at positive cos raised to the power of 4 at times dt. Right, this is what we have got. I hope you're following. Now what is the integral that we add? Let me show you the problem. The problem is L is equal to integral 0 to 4 pi e raised to the power of t times sine raised to the power of 6at positive cos raised to the power of 4at times dt divided by integral 0 to pi e raised to the power of t times sine raised to the power of 6at positive cos raised to the power of 4at times dt. This is what we are, right? But what is this? This is equal to this. So you substitute that. This is nothing but 1 positive e raised to the power of pi, e raised to the power of 2 pi, positive e raised to the power of 3 pi times integral 0 to pi e raised to the power of t sine raised to the power of 6at positive cos raised to the power of 4at times dt divided by integral 0 to pi e raised to the power of t times sine raised to the power of 6at positive cos raised to the power of 4at times dt. Now these two can be cancelled, giving me 1 positive e raised to the power of pi, positive e raised to the power of 2 pi, positive e raised to the power of 3 pi. But we can sum this up, right? If I were to sum it up, this will produce me a quantity. So the quantity of this sum will be equal to 1 multiplied with e raised to the power of 4 pi negative 1 divided by e raised to the power of pi negative 1. So this is the final solution for any a element of R. Okay, I hope you are watching it. So that's the conclusion for this question. We move on to the next one.